Hello everyone, it's good to see you. We're going to be looking at arithmetic sequences this week. Fancy, fancy. And it's the last week before break, so that's really exciting. I hope that y'all are getting ready to have some nice time off and enjoy yourself and relax. So this will be our lesson for this week, and here's the first part is our Peardeck. So make sure you're opening up that Peardeck of your own and that you're writing your name on that first slide. If you want to do these notes on paper, you can always do that. Just make sure you're sending me pictures of your work, okay? Because I know some people prefer to do it on paper, and that's totally fine. So cruise ahead to slide 2 when you are ready. And we're going to fill in some vocabulary. So what we're talking about this week and then the week after break are sequences. And a sequence is a list of numbers that follow a rule, right? The sequence that we're looking at this week is going to be following a linear pattern. Each number in the sequence is called a term. So we have the first term, the second term, the third term, the 100th term, all of these numbers in a sequence. And the one that we're looking at this week, like I said, is arithmetic. And an arithmetic sequence is a special type of sequence formed by adding the same number to each term. So when we're looking at an arithmetic sequence, they're always going to be adding the same number to get the next term. Okay? And we call this number the common difference. And that is the constant difference between any two consecutive terms of an arithmetic sequence. When we're talking about our difference, we use the letter D. And I also want to note that we see this word consecutive. So consecutive means right after each other, right? So the one right after it. So make sure you get these vocabulary notes on your slide, whatever you need, and when you're ready, push ahead to slide 3. So let's look at some sequences. And there can be all types of sequences, right, that happen. They are going to have different patterns. We, this week, are focusing just on arithmetic sequence, which means to get from one to the next, we must be adding the same number each time. That's the key, right? So it specifically has to be addition and it has to be the same number. That is going to make it an arithmetic sequence. So let's look at this first one. We see 1, 3, 5, 7. And we're wondering, if this is arithmetic, and then what is the common difference if it is? So you just look at, okay, how do I get from 1 to 3? I add 2. 1 plus 2 is 3. Okay, let's see, how do we get from 3 to 5? I also add 2. 3 plus 2 is 5. 5 to 7, also add 2. So yes, this is arithmetic, and our common difference is a positive 2. Notice we also have this dot, dot, dot at the end that tells us it's continuing on in this same pattern. And the pattern that we discovered is we're adding 2 each time. Over on the right, if we're wondering if this is arithmetic, notice these numbers are getting smaller. So we're going to be thinking of subtraction or adding a negative number. So 7 plus negative 3 is 4. 4 minus 3 is 1. 1 minus 3 is negative 2. So yes, this is arithmetic. It looks like subtraction. That just means our common difference is negative, right? If we're subtracting 3, remember that's the same thing as adding a negative 3. Subtraction is just adding negatives. Beautiful. So we have two arithmetic sequences and we see their common difference. When you're all set, push ahead to slide 4. Same thing. Are the following sequences arithmetic? And if they are, what is the common difference? So we just do a little investigating at first. 7 to 12, we can see it's getting bigger, so we're going to be adding a positive number. 7 plus 5 is 12. 12 plus 5 is 17, so that works. And 17 plus 5 is 22. So yes, this is definitely arithmetic, and our common difference is a positive 5. Over on the right, to get from 3 to 6, we're getting bigger, so it's going to be a positive number. So we have positive 3. 3 plus 3 is 6. And then to get from 6 to 12, we add 6. And then to get from 12 to 24, we're adding 12. So we can see each of these numbers are different. So this is not arithmetic. It's still a sequence, right? And there is a little bit of a pattern happening, but it's not specifically an arithmetic sequence. And then push ahead to slide 5 when you're ready. And if at any point you need to pause the video to get caught up on notes, please always do that. So when you're writing an arithmetic sequence, follow these notation rules. So we use this letter A. Specifically, we're going to see A with the little number 1 to represent our first term. And D is going to be our common difference. So to describe this using that notation, we have, what is our first term? Looking here, just look at what's in the front, and we see a 4. Great. Our first term is 4. Our common difference, well, to go from 4 to 7, it's getting bigger, so we're adding a positive number, positive 3. And then you just want to check to make sure it works for the other ones. 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. So yeah, our common difference, or D, is 3. So we can kind of get this information here to tell us a whole sequence, right? To know where we're starting and then what we're increasing by. What is that difference? Push ahead to slide 6. Same thing, describe the following sequence using precise notation and then find A of 10. Okay. So we're starting at 16. That's our first term. So A of 1 is 16. We notice that these numbers are getting smaller. 16 minus 4 is 12. 12 minus 4 is 8. 8 minus 4 is 4. So our common difference is a negative 4. And right now we have the first 4 terms, so I'm going to write them over to the side. 16, 16, 12, 8, 4. And again, this is our first 1, 2, 3, 4 terms. And we want to find our 10th term. So I'm just going to write 5, 6, 7, 8, 9, and 10. And each time we're just still subtracting 4 because that was our common difference of minusing 4. So 4 minus 4 gets us 0 for the 5th term. 0 minus 4 is negative 4. Negative 4 minus 4 is negative 8. Negative 8 minus 4 is negative 12. Negative 12 minus 4 is negative 16. And finally, negative 16 minus 4 is negative 20. So our 10th term following this sequence pattern is a negative 20. Okay. So we can always find whatever term we want in the sequence. We may have to like make this list and just make our way to that number term. Let's push ahead to slide 7. And if we want to find a faraway term, for example, the 100th term, that's going to be hard. Like we could make a big list and go all the way to our 100th term, but that could take a long time. So when we're working with arithmetic sequences, we can use this formula, which is a sub n is a sub 1, which means the first term, plus n minus 1 multiplied by d, our common difference. So let's try it out. If we wanted to find the 100th term of this pattern, so this pattern that I see here, our first term is a 3. That's how it starts, so that's what we're going to put right here in our formula. The difference is 5, right? 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. So that's what we're putting out here. So here's our difference, and here's our first term. Now we plug in a 1, and the n is whatever number term we're trying to find. So we're trying to find our 100th term, so our n is 100. That's why we see 100 here and here. Right, we're finding the 100th term, so we're plugging in 100. So a of 100 is 3 plus 100 minus 1 is 99 times 5. So we have 3 plus, I would go to my calculator, and I have 99 times 5, which is 495. And if I add 3 to that, I get 498. So if we keep going up by 5 each time, our 100th term is going to be 498. So we don't have to make out this huge list going to 100. We can use this formula to get ourselves there. So once you have everything you need, push ahead to slide 8, and we're going to look at another practice problem using this formula. Okay. And I think I'll also pause the video here, and then I'm going to make a part 2. So I'm going to pause it and make a part 2 because there's like 4 or 5 slides left. Okay. See you in part 2.